Hello viewers, welcome back to my channel. My name is Michael, and in today's video we will be treating quadrilaterals. In our previous one we did triangles, so we want to finish with the plane geometry by ending it with quadrilaterals. So in today's videos we will be going through the types of quadrilaterals, and then we have a past question and a question on the board relating to quadrilaterals. After everything, we will be going through the question and see how best we could solve the question on the board. So let's start. When we talk of a quadrilateral, what is a quadrilateral? A quadrilateral are diagrams which are enclosed with four sides. The quadrilaterals are plane figures which are enclosed with four sides. So any form of enclosed plane figure with four sides, we call it quadrilateral. And so you could see on the board we have one side, two side, three side, and then the fourth side. So we have this as quadrilateral. Good. And we have a general property that runs through all types of quadrilateral, which is the interior angle of all quadrilateral sum up to 360. So if I have A, B, C, D here, then A plus B plus C plus D should be equal to 360 degrees. So the interior angles of all types of quadrilaterals, they add up to 360 degrees. Good. So now let us start with the types of quadrilaterals. So I want to begin with square as the first type of quadrilateral. So a square this is not drawn to scale, but the axe on it determines that all sides are equal. So a square has all of its sides equal in length. That is the first property of a square. All of its sides are equal in length. And then the second property is that each interior angle is 90. So we have 90 degrees here, 90 degrees here, 90 degrees here, 90 degrees here. That is the second property of a square. Each interior angle is equal to 90 degrees. Now, with the general formula or the general property, we've done that already. We say that all interior angles add up to 360 degrees. Now, how many lines of symmetry do we have in here? We have all sides equal. And so, if we have a line drawn this way, of course, in our previous video, we discussed what a line of symmetry is. So we said a line of symmetry is a line that divides a diagram in a way that we can fold one half exactly onto the other one. So we have some instance where the line divides the diagram into two equal halves, although, but then we can't fold one half exactly onto the other one, and so it is not the line of symmetry. But in this situation, this line is dividing the diagram into two equal halves, as well as one half of it can be folded exactly onto the other one. And so we have a first line of symmetry, and then also our second line of symmetry this way. This can be folded exactly onto this one. So far we have two lines of symmetry. And then our third one, we will go this way, another line of symmetry. We can fold this half exactly onto this one. 3 lines of symmetry. And then the last one, we can divide it this way, and this half can be folded exactly onto this one. And so a square has 4 lines of symmetry. That is all for square. Let's move on to our next type of quadrilateral. So, our next type of quadrilateral is the rhombus. The rhombus. We have the rhombus on the board, and then it has some common property as the square. And the common property is that all of its sides are equal in the size of its length. So this length is equal to this one, equal to this one, and equal to this particular one. So that is the first property of a rhombus. And also, we have another property which says that opposite sides are parallel. And so, as you can see, I have 2 arrows on this line, and so this line is parallel to this one, as well as this line is also parallel to this line. So opposite sides are equal and parallel. Good. And so the third property is that opposite angles are equal. The third property, opposite angles are equal. We have this angle here equal to this particular angle. A rhombus has opposite angles equal, and so this angle also is equal to this particular angle. That is another property of a rhombus. And so our third property of a rhombus is that diagonals intersect at right angle. So the line that divides the diagram this way and the line that divides it this way, they intersect at right angle. Which means that their intersection forms 4 angles which are 90 degrees. Good. Now, it has 2 lines of symmetry, because you could see on the board, this line divides this diagram in a way that you can fold this half exactly onto this one, and also this one divides this in a way that we can fold this particular half also exactly onto this particular half. So a rhombus has 2 lines of symmetry. Now, if we should have an example on this, which says that if this diagram is a rhombus and I have, let's say, 75 degrees here, out here, and now the question says you should find A and then find the value of A and then B this way. Good. We can use the parallel lines, although, but let's use the property we just made mention of, so that you will be familiar with the property. Now, we could put a variable here, let's say x, in order to help us solve for this particular 2 angles. Good. X plus 75 are supplementary, and so they should add up to 180. They are on a straight line. So I have my x plus 75 degrees should be equal to 180, because supplementary or straight line angles add up to 180. And I should have my x equal to 180. This being transposed 75, and then our x then will turn to 105 degrees. So we have our x to be 105 degrees. Now, we said in a rhombus, one of the properties says that opposite angles are equal. So you don't need to solve for A. Straight away, A is equal to x. That is, A is equal to x is 105, so A is equal to 105 degrees because opposite angles of a rhombus are equal in size. Good. Now, A plus B is equal to 180 because they are co-interior angles. Since this line is parallel to this line, and also this line becomes the transversal line. And so, whenever they are within the parallel lines and they are at one side of the transversal line, we say they are co-interior angles. And so, A plus B should be equal to 180 because co-interior angles add up to 180. And then after that, we know our A to be what? Equal to 105 degrees plus our B should be equal to 180. And then we have our B equals 180 less our 105, and our B equals what? 75 degrees. Good. Now, we could also see that even without solving for B, we already know our B is 75 because we said corresponding angles are equal. The angle beside this parallel line, this one arc line, this way, is equal to the one also beside it at the same side of the other parallel line, which we say they are corresponding. So this B is corresponding to this 75 degrees. So even without solving for it, straight away, corresponding angles are equal. And so B is equal to 75 degrees. Let's move on to our next type of quadrilaterals, which we have a rectangle. So with a rectangle, opposite sides are equal and parallel. So this is equal to this one, and this is also equal to this one, and they are also parallel. After that, we have each interior angle is also 90 degrees. This way, nicely on the board. And then now to the question 2, how many lines of symmetry do we have here? You could see and you could realize that if we should divide this diagram into 2 equal halves this way, you see it is dividing the diagram into 2 equal halves although, but this half cannot be folded exactly onto this one. This could appear somewhere here. And so this is not considered as a line of symmetry. And so in a rectangle, we have only 2 lines of symmetry, which is this line here. If we should divide it this way, we can fold this half exactly onto this one. And then the second one is that if we should divide it this way too, we can fold this half exactly onto this one. So a rectangle has 2 lines of symmetry. Good. Let's move on to our next type of quadrilateral, which is a parallelogram. A parallelogram. Good. So, with our parallelogram too, opposite sides are equal and parallel. And then we have these 2 equal to this one, they are also parallel. That is the first property of a parallelogram. The second property is that opposite angles are equal. That is a parallelogram. So I have these 2 arcs here. This angle is equal to this angle, as well as this angle is also equal to this particular angle. Good. Now, you can see on the board, if ABCD is a parallelogram, if ABCD, the bigger, the outer quadrilateral, is a parallelogram. So it means that if this is a parallelogram, then if I have 84 degrees here, then I'm supposed to have 84 degrees here as well. Because we are saying that with a parallelogram, opposite angles are equal. And so this side is also equal to this side. So if this is a parallelogram, then this angle should be equal to this angle. Now let's proceed. The third property of a parallelogram is if I have A here and B here, then we are saying that A plus B should be equal to 180. This is because what? Co-interior angles add up to 180. And parallelograms has no line of symmetry. They have no line of symmetry. Good. So that is it for parallelogram. Let's move on to our next type of quadrilateral, which is our kite. So we have kite. Now, a kite has two adjacent sides equal in length. So you could see two arcs on this. You could also see two arcs on this. So this line is equal to this line. You could have one line here, one arc here, one arc here. So this line is also equal to this line. So the first one is that it has two adjacent lines equal in length. That is the first one. The second one is that diagonals intersect at right angle. So we have 90 here, 90 here, 90 here, and 90 here. Good. So we have four right angle triangle in a kite. Good. When you get to mensuration, you need this. Good. Let's proceed. The next property is that a kite has one line of symmetry. You could see this particular line dividing the diagram into two equal halves, and so this half can be folded exactly onto this half. Good. So a kite has what? One line of what? Symmetry. And then also it has one pair of its interior angles equal. And so if I have A here, I should have A here. This angle is equal to this angle. Now on the above two, we are saying if ABCD is a parallelogram, which is the outer one, and BCDE is a kite on the board, then we should find the value of y. Now, this BCDE, this is the kite we are talking about. So we are saying that this line here is equal to this line, and this line also is also equal to this line. Good. And so if I have 73 here, then I'm supposed to have 73 here, because we are saying that one pair of its interior angles are equal. And this is a pair of interior angles, just as this one too. This is a pair of interior angles which are equal in size. So this 73 is equal to this angle, which is also what? 73 here. Now let's move on. So that is all for kite. And of course, the sum of its interior angles add up to 360 degrees. Let's move on to the last one on my list, which is the trapezium. The trapezium. Good. I have my A here, B here, this way. So trapezium to opposite lines are equal and parallel. You can see this line is parallel and this line is parallel to this one. So that is it on the board. And also we could also have a trapezium drawn in this way. You could also have it in this way too. Good. So A, B, C, D. C, D. So opposite sides, one of its opposite lines are what? One pair of its opposite sides are parallel. Good. And after that we have A plus B is equal to 180. This is because what? Co-interior angles add up to what? 180 degrees. Good. And that is all for trapezium. Now let's get into the question and see how best we could solve for y. Good. So, if this is a parallelogram, as said earlier, we said parallelogram. In parallelogram, two adjacent angles add up to 180. Two adjacent angles add up to 180. And opposite angles too are equal. And so, if I have this angle here, angle ADC, should be equal to angle ABC. Angle ABC, because opposite angles of a parallelogram are equal. And so if I have y here, then I should have y here. Good. And so if this is ABC, which is y plus 73, then it should be equal to y plus 73 here too as well. Good. And now from here we can solve for y in a simple way by saying the sum of interior angle of a quadrilateral sum up to 360 degrees, or adjacent angles of a parallelogram, they add up to 180. So if we want to use the adjacent angle of a parallelogram, then we could say y plus 73 plus 84 here should be equal to 180 degrees. Good. As you can see on the board, the whole of this angle here plus this angle add up to 180 degrees because co-interior angles are equal. Good. So co-interior angles add up to 180. Good. Let's proceed. Now, our y here plus our 73 here plus this will give us 157. Should be equal to 180. So our y will be equal to 180 less 157 degrees here. And then our y will then be equal to 23 degrees. Gentle. So y is equal to 23 degrees. Or we can sum everything up to 360. So we could have 84 degrees here plus y plus 73 here plus 84 here plus y plus 73 should be equal to 360. So y you can add like terms. So let's bring them together. Y plus this y here plus 84 plus 73 plus 84 plus this 73 should be equal to 360. Good. So this plus this will then be 2y. We can add or subtract like terms. Good. We have 84 here plus this 84 here will be 168. So we have 168 here. And then our 73 plus our 73 here too will be 146. Good. So 8 plus our 6 here, we'll have 14. Write one here. The next one join this one. This plus is 10 plus the 1, 11. Write it here. The one join here. We have our 314. So plus our 314 here should be equal to 360. You have our 2y equals 360. This has to join this. Less 314. Then you have our 2y should be equal to 360 degrees less 314. will then give us 46 degrees. So we divide both sides by 2. Then we have our y equal to this into this 23 degrees. Thank you so much. This brings us to the end of quadrilateral on my channel. If this has been helpful, share with your friends and also press on the subscribe button. Thank you so much for today.